Alright, here is a short video guide for lesson 126, focusing on the different types of symmetries we see in geometry. So we're going to focus a little bit on translation symmetry, reflection symmetry, and rotational symmetry. And by the end of the lesson, we should be able to explain these questions, and I think we will try to explain them in the learning log. Okay? First thing is just a drag if you agree or disagree. So the statement is, I understand and can visualize how to transform shapes. If you agree, you can slide this up, or if you disagree, you can slide it down, and you have room here to explain your choice, or leave me a question if you need to. Okay, here is just an example of reflection symmetry. So this dotted line that cuts the shape down the middle, that would be a line of reflection, because if you folded about that line of reflection, it would land perfectly on top of each other. So we're going to use that kind of idea of lines of reflection on the next problem, and so it's nice to see this visual. Alright, here we have this reflection symmetry, and we need to figure out what shapes in this list over here have more than 3 lines of reflection. Okay, so line of reflection again is a line that you could cut the shape and it would fold onto each other. So a regular hexagon, if you cut it right down the middle, it would fold onto each other. And you can see there's 3 different folds or 3 different cuts you could make so that could happen. And so you would write regular hexagon. Okay, that's the one I'll give you. Go through them, and I wish I would have done a little bit better job in giving you a tool so you could actually draw it out, so I do apologize. But go through them and say which of these shapes have 3 lines of reflection on them. Okay, if you have questions, please email me. Here we have rotational symmetry now, and rotational symmetry, so reflection symmetry was if you can cut it and it folds onto itself, it has a line of reflection, it has some type of reflection symmetry. Rotational symmetry is you can spin the shape about a point so that it lands on top of it again and it looks exactly like when it started. Okay, so they're asking, does this shape have rotational symmetry? And you can use this E tool here to investigate it, and you can when you click on it, it should be able to tell you what degree it has rotational symmetry at. By the end of this lesson, I'll explain a way that you can find those degrees of rotational symmetry by just using a calculation. But investigate that using the E tool. Here it says, Jessica claims that she can rotate all figures in such a way that they will not change. How does she do it? Now I'm actually going to give you this one because just thinking logically through it, there is a way that any shape you can rotate. If you take a shape and you hold it at the center and you spin it 360 degrees, you will end up having the shape that you started with. So spinning a shape 360 degrees about its center, and you'll always end up with the same shape, because it's like if I was standing on the ground and spun 360 degrees, I'm facing the same way as when I started. It's that same idea. Okay? So now we're talking about these same shapes again, and we're talking about rotational symmetry. So it says, since all figures can be rotated 360 degrees without change, we need to find ones that don't have 360 or some degree less than 360 where we get that rotational symmetry. So the one that I will do for you here is the rectangle. The rectangle has rotational symmetry at 180 degrees because if I flip that rectangle over, it looks exactly the same as it did before it started. Okay? Now it's also going to ask which ones have 90-degree rotational symmetry. So go through, read that question closely, and again, if you have questions on that one, it's a little tough because you can't move the shapes around, so you have to visualize it. So if you have questions, please let me know on this question, 1-100 rotation symmetry. Okay, translation symmetry. We have another example here where I'm going to kind of explain this one, kind of give this one to you. Because we talk about reflection symmetry having lines of reflection. We talk about rotation symmetry being able to spin a shape less than 360 degrees so that it looks exactly the same. Now we're talking about, is there a way that you could take a shape, let's say like a square, I know it's really bad, and you could translate it. So maybe I slide it over to the right, and then it lands on top of itself again. Now, we know a translation by this point. When you make that slide, it's not going to change the shape. Even though I know my drawing's not great, it's not going to change the shape. If it's a square, it's still going to be a square. But the issue with this problem and the issue with translation symmetry is you've slid it away, and so it's not landing on top of itself again. And for it to have symmetry, it needs to land on top of itself again. And so by just making a translation, you're kind of breaking that symmetry. And so there is no polygon that has translation symmetry. And so I want to put that on there. There is no polygon that has translation symmetry. Okay? Because in the nature of translating, like I said, you're sliding it away. And you'd have to slide it back. And that's just, again, the original shape. So if you want to see something that has translation symmetry, you can Google tessellation. If you Google tessellations, and that might not be spelled right, and my apologies if it's not, tessellations are something that have translation symmetry. Okay, now this one you can draw on, and here we're going to try to find all the lines of symmetry on this dodecahedron. Okay, so it's just drawing the lines of reflection. I'm going to give you one right here. That right there would give a line of reflection, because if you cut that in half, it would fold perfectly onto their side. You need to find the others. Okay. Describing rotational symmetry. This one I'm actually going to, this is kind of an important one, so make sure this is something you remember. What rotation carries this onto itself? So we know that the point of rotation is going to be the center, if we rotate a polygon about its center. But how many degrees do we have to rotate it so that it's going to land on top of itself? Well, I'm going to put it in the shape because I don't have much room to work here. But what you can do is, or maybe I'll type it in here. What you can do is 360 degrees, because there's 360 degrees in like that full circle if you were to spin it all the way around. And then you can divide it by the number of sides. And this is a dodecahedron, so it's a 10-sided shape. And if you do that 360 divided by 10, that would give you 36 degrees. And if you rotate this shape 36 degrees, it's going to land, it's going to look exactly like it does here, and it's going to land right on top of itself, and it's going to have that symmetry. So 36 degrees is one of them, and then every 36 after. So 36 gave you the rotational symmetry, and then 36 plus 36, so 72 degrees would give you another rotational symmetry. You could add 36 again, and that's 108. Would give you another rotational symmetry. So everything between 36, and you could keep going up until 360. Okay. Now that rule here of 360 divided by the number of sides, in this case happened to be 10, is important and something to write down and something to remember. Lastly, the translation symmetry. Like I said in earlier slides, there is no translation symmetry for a polygon, and a polygon is just a how many sided shape. Even if it's 10-sided, still doesn't have that translation symmetry. So there is no translation symmetry here. Then the last one is just the learning log, and it's asking those 3 questions from the beginning of the lesson. What is the symmetry? How can I determine if a polygon has symmetry? And what types of symmetry does a shape have? And so just go through again and reflect on the lesson and try to answer those 3 questions. And again, I go through this kind of quickly now for the sake of just having you try to discover more. But if you have any questions, please don't write, I don't know. Please don't write, I can't figure this one out. You just need to email me, and I'm happy to help make a video guide, or not a video guide, a video help for any problem on here. And that goes for the homework as well. So please, please reach out and ask me if you need any help.